Hi, this is Josh Strain, and we're going to be talking about glyphosate and its impact on human health. We're going to look at some known mechanisms and some theoretical mechanisms by which it impacts your health. So, I don't want to spend a lot of time here, but just so we're all on the same page, what is glyphosate and why is this an important issue? It is the active ingredient in Roundup weed killer. Now, this weed killer is sprayed on fields of crops that have been genetically modified to be resistant to it, so it ends up killing all the weeds while leaving the food crops intact. And it is also sprayed on non-genetically modified crops as a desiccant. It dries them out, it prematurely ripens or kills them so that they can be harvested. So, about 288 million pounds of glyphosate were sprayed on US farms in 2016 alone, let alone what happened before that, let alone what happened after that. 288 million pounds of pure glyphosate. We're not talking about Roundup, we're not talking about all pesticides, all herbicides, pure glyphosate. 288 million pounds of this stuff, 3/4 of a pound pure glyphosate per acre of harvested crops in this country. And increasing percentages of tested food in the United States are showing to have glyphosate residue. Surprise, surprise, including organic food. Now, organic food is not genetically modified and should not be, you should not be using herbicides, synthetic herbicides on organic food. So how is organic food having glyphosate in it? Well, it turns out glyphosate is very water soluble, and it also has a very low molecular weight. It's a very small molecule. So it's easily transported in water and by wind. Say you have two farms next to each other, one farmer's spraying glyphosate, the other one's not. The wind can very easily carry it over. And it's been shown that up to 10% of the glyphosate application can actually affect fields nearby just from wind drift. So that's one way, and also it accumulates in the water supply and comes down in the rain. So that's how organic food has glyphosate. So it is increasingly showing up in our bodies. One study of Southern Californians found that glyphosate levels in their urine were 13 times higher in 2016 than they were in 1996. 20 years, the glyphosate in people's body has gone up 13 times, not 13%, 13 times. And levels of AMPA, which is the byproduct of glyphosate degradation in your body, increased 36 times in the same people. So they also found that the amount of people who had detectable levels of these things grew. So more people have more glyphosate and AMPA in their bodies. Just to give you a quick visual of what the application looks like. So this red line here is the amount of non-agricultural. So that's like you go to Home Depot and buy a gallon of Roundup and spray it in your driveway to kill the dandelions. But this blue line is what we want to focus on, and that is the commercial application. And we already said that this has exceeded 288 million pounds in 2016. And remember, this is not cumulative. This is every year. It's getting more and more and more, in addition to what was done the previous years. And this is important because I hear a lot of people say, well, you just wash that stuff off. I don't need to buy organic. I'll just wash my produce off. You can't wash it off. It works intracellularly. It gets into the cells of the plant. It doesn't just sit there on the surface waiting to get rinsed off in your sink with a little warm water. It's inside every cell of the plant. And plus, it's been shown to be in processed foods, oatmeals, crackers, breads, cereals. How are you going to wash it off your oatmeal? You can't do it. So don't give me that. Here is just one quick little example of the foods that contain glyphosate. You'll see a list of popular foods there, including Whole Foods crackers, and also Stacy's, which is the healthy brand of pita crackers, had the most glyphosate. Now, they don't claim to be organic or anything, but still, people have an image of Stacy's as being a healthy brand. You know, look at the glyphosate there, 800 parts per billion. And you can find these kind of reports all over the internet. This is just one example. So, known mechanisms of glyphosate. We're going to talk about how we know glyphosate affects your body. A, causes intestinal hyperpermeability. We'll talk about what that means. It kills the good bacteria in the soil and in the food and in us. It binds to beneficial minerals in the soil, in the food, and in us, and it makes them unusable. It also suppresses many of our detox enzymes, and it inhibits glycine synthesis. And we'll talk about what that means later on and why that's important. This is all the stuff that we know glyphosate does in our body. So let's start with causes intestinal hyperpermeability, because really I think that's the core issue, because if glyphosate could just travel through your intestines and get excreted, it wouldn't be so much of a problem. But because it causes permeability, it then gets into your bloodstream along with many other things, and that's where a lot of the damage is done. So let's look at that. So we see here a picture of the lumen of the small intestine. So that's your food passing through here, and these are your cells, and then this is your bloodstream. And you can see it's kind of a simplistic picture, but it'll do. You see the tight junctions between the cells here, and they help regulate the food that stays in your intestine. And once it's been fully digested, amino acids, nutrients, minerals, all those things can get into the bloodstream. But the problem is when you have dysregulation in the tight junctions, and this says no tight junction. That's not exactly correct. We're talking about just dysregulated. So the tight junctions are open and they allow these things in there unselectively. So then things get into your bloodstream that should not be there. And glyphosate has been shown to dysregulate the tight junctions in a dose-dependent manner. And we'll see a slide on that next. And then what happens is these large molecules that should not be in your bloodstream get in there, and this includes undigested food. It includes bacteria from your intestine that shouldn't be in your blood, and it also includes glyphosate itself. So glyphosate opens the door, and then more can go into your bloodstream. And of course, other toxins as well. Now, these foreign particles are tagged and targeted by the immune system, causing inflammation, which is probably, in my opinion, the biggest reason, if not the only reason, food allergies and autoimmunity are exponentially on the rise these days. So not only does glyphosate dysregulate your tight junctions, it also kills the bacteria that help regulate and heal the tight junctions. So it's like a double whammy. It causes the damage, and then it inhibits your ability to fix the damage. So that's what we're talking about when we're talking about glyphosate. And this is the key issue, because now the tight junctions are dysregulated and glyphosate can get into the bloodstream and do other damage, which we're going to look at. Yeah, just real quick, this is a study that showed glyphosate killed a lot of the bacteria that produce butyrate. And at the same time, it increased the population of pathogenic bacteria. So decreasing your body's ability to heal the gut lining. So here's that slide, the damaged tight junctions. This is the F-actin filaments. You can see in frame A here, this is 0 glyphosate applied. This is what human intestinal cells look like normally. It just looks vibrant and dynamic and organized, and like there's life there. And then progressively you can see the more glyphosate they add, it just gets continually dysregulated, damaged, and chaotic. It just looks like you don't want to have that happening. But what it's actually showing you is the damage to the F-actin filaments, which are part of those tight junctions. So you're actually seeing what glyphosate does in between your cells in these slides. So that is pretty powerful. Now, granted, 20 milligrams per milliliter is a high dose of glyphosate. You know, I don't think anybody could ingest that much at once, but it does bioaccumulate in your body, and that's been shown in animal studies that I haven't included here, but it does bioaccumulate. So eventually you're going to reach levels where this is happening. And even if it's not happening to this extent, you know, any little bit of glyphosate is going to do this to some extent. And you just don't want that happening. So we talked about glyphosate killing good bacteria. You can see, let me move myself out of the way here. It was patented as an antibiotic because what it does is it targets the shikimate pathway. Some people say shikimate, I say shikimate. I've heard it both ways. But you can see it on the right-hand side here, the shikimate pathway. Now this is what's present in plants, and this is what glyphosate targets to kill the plant, because then the plant cannot proceed with this pathway to make these crucial amino acids, tryptophan, phenylalanine, tyrosine, and it can't rebuild itself, it can't grow new cells, and it dies. And that's how glyphosate kills plants. Guess what? It also kills bacteria that have that pathway, and that's what this patent says. It inhibits the 5-enolpyruvyl shikimate 3-phosphate synthase, and in doing so, it kills the organisms that have that pathway. Now, Monsanto says humans don't have the shikimate pathway, therefore, there's no harm for glyphosate to do because we don't have the pathway on which it acts. That's true, but guess what? Many of our gut bacteria do, and these happen to be mostly the beneficial gut bacteria have the shikimate pathway. So yes, it doesn't directly affect us in terms of, you know, blocking this pathway, but it does kill beneficial bacteria in the gut, which we saw in the previous slide, and now we're seeing again. And then, of course, the helpful bacteria decline, so that leaves open the terrain for the pathogenic bacteria to increase. Of course, it also does this in the soil in which the food is grown, and people smarter than me have estimated that the diversity of bacteria in the soil has decreased by 80%. Since I believe the early 1900s. Now, I could not find documentation on that. I'm just telling you, this is what I've heard from people who know what they're talking about, although I could not find specific documentation.